Today we're going to talk about circles, and we know from geometry that a circle is the set of all points in a plane that are a fixed distance from a point, and the point that we're talking about here is just the center of the circle. And the center, we usually use the coordinates h comma k, just like we use h comma k as the vertex of a parabola. But for the center of the circle, we use the coordinates h comma k, and the fixed distance is just the radius. And you all know that we use the letter r for our radius. And so here they've asked us to find the radius of this particular circle. We're given the center and we're given a point on the circle. So we can use the distance formula to find the radius. So we're just saying radius here equals the square root, and we'll do the difference in the x values, so just 4 minus 2 squared, plus the difference in the y values, which is just 6 minus 3 squared. And so we end up getting 2 squared plus 3 squared, which is just going to be the square root of 4 plus 9, which is just the square root of 13. And so now they want us just to double check that this radius is correct using this other point on the circle at -1, 1. So let's plug the center and that point in to our distance formula to see if it's still the square root of 13. So we're going to do the difference in the x value. So we're going to do 2 minus a minus 1. So 2 plus 1 squared plus the difference in our y values, which is 3 minus 1 squared. This ends up giving us the square root of 3 squared plus 2 squared, which is the square root of 9 plus 4, which does in fact still gives us the square root of 13. So we know that that radius is correct. Now they asked us to find another point on the circle. And you notice that if we look at when we were finding the radius in both cases, we either had a difference of 2, say with the x's, and a difference of 3 with our y values, or it could be vice versa. So if we think of a difference of 2 from our x values, maybe we could say our x coordinate or an x point on the circle could be 4. So if that's a difference of 2 from here, we'd have to do a difference of 3 from our y value, which could potentially be 6. Or we could even go the other direction. If we wanted to have a difference to be 2, we could just subtract 2 from that. So we'd have 0 for our x value, and it could be 0, 0 for our y value. Again, our x values have a difference of 2, our y values have a difference of 3. Or you could do a reverse. You could do the x values that have a difference of 3. So maybe you said the x value was 5, and the y value had a difference of 2, which would be 5, 5. All of these points should be points on this particular circle. Again, every point on this circle is going to be the same distance from the center. So if we took each of these 3 points and used the distance formula with the center, we should all get that the radius is that square root of 13. So because of that, we can write a general equation that works for every point on the circle. And we can denote every one of those points as just a generic x comma y. And so this gives us our distance formula, our general equation for a circle. And here, what we have, again, our center is h comma k, and our radius is r. And so the general equation of a circle is just r squared equals x minus h squared plus y minus k squared. Again, you'll notice when we're finding the center that x and your y coordinate are the opposite sign of what you're given in the equation. So the x and y coordinate are opposite sign from the equation. So let's take a look at a few examples. We're given the equation of a circle and how we can pull the center and the radius. So looking at this equation that we're given, again, we're going to look at the opposite signs to pull our center. So our center here is going to be at 2, -1. So let's go in and plot that point at 2, -1. And our radius squared equals 4. So if our radius squared equals 4, then our radius must be 2, because we just take the square root of both sides. Now I can really just go up and down 2 or right and left 2, which gives me a good enough idea of how I can sketch my circle. And let's do the same thing over here. Let's look. We've got our center, which is going to be the opposite sign, so -1, -2. And then our radius is just going to be the square root of 9, which is just 3. So I have -1, -2, and my radius is 3. Count over 3 spaces, up, down, right, and left, and I can draw my circle. Now if we look at this next equation, they want us to write the equation of the circle. So first we need to identify what our center is. And we see the center is at -1, -2. Now remember, our general equation of our circle is r squared equals x minus h squared plus y minus k squared. And here is our value of h and k. Now we found our center, so now we need to find our radius. And we can just go either to the right, left, up, or down. And I'm just going to go to the right. We've got 1, 2, 3, 4, 5. So we know our radius equals 5. So if we just pull all this into the equation, r squared is going to be 25. We have x minus h, so it's x minus a -1, or x plus 1 squared, plus y minus a -2, which gives us y plus 2 squared. And there is our equation of a circle. Now, we also could be asked to write the equation given the center and the radius, which is pretty much what we just did. I want you all to pause the video and come back and check your answers here. Just be careful when you have a radical. Remember, your equation still calls for a radius squared. So you'll notice here in number 5, it really doesn't matter which side of the equation I put the 36. And you'll notice also that when I do x minus our h value and y minus our h value, which is why that becomes y plus 5. On number 6, I went on and wrote this out because our center was at 0, 0, but that can simplify just to x squared plus y squared. And then when I square 2 radical 5, 2 squared gives me 4, and the square root of 5 squared gives me 5, and 4 times 5 gives me 20. So let's take a look at some other equations here. They say write the equation of the circle with the center. So we know that our center is at -2, 3, and they say that this circle passes through the point 3, 7. So they don't directly tell us the radius, but they tell us enough information to find the radius. Because if we just sketch that point at -2, 3, and then we have over here a point on the circle that's at 3, 7, we know our circle goes like this, and we're just trying to find that radius. So our radius is just going to be the square root, or really just the distance between these 2 points. So we'll take the difference in our x values. So we have 3 minus a -2, or 3 plus 2 squared, and then 7 minus 3 squared. So 3 plus 2 squared gives us 5 squared, which is 25. And then we have 4 squared, which is 16. So the radius is going to be the square root of 41. So once we know the radius, we can put this with the center into the equation for the circle, which is going to be x minus h, so x minus a -2, which will be x plus 2 squared, plus y minus k, or y minus 3 squared, and it's going to equal r squared. And remember, r squared is just going to be the square root of 41 squared, and the square root of 41 squared just gives you 41. So I want you all to try this next one. Now this one's a little bit different. They don't give you the center. They give you the endpoints of the diameter. So what are you going to have to find first? How do you find the center? Right, we've got to use the midpoint formula to find the center, and then just like we've done previously, we can use the diameter to find the entire length of the diameter, and then just divide it by 2 to find the radius. So why don't you work on that and come back and check your answer. So you should have found here, you should have found your midpoint of the endpoints of the diameter. That midpoint, remember, is just the center, and that's going to be at 5, 8. Then we could use the endpoints of the diameter to find the whole length of the diameter, which we found that to be 2 radical 13. And then you're just going to divide that by 2 to get your radius. So your radius is just the square root of 13. So now we use our center and our radius and just plug it into the equation. Again, x minus h squared plus y minus k squared, and then it equals r squared, and the square root of 13 squared just gives us 13. So now let's talk about what happens if we're given an equation of a circle in standard form and we need to get it into this form up here that we talked about earlier, this general equation of a circle. And so we're going to learn how to complete the square with a circle. Now, I've outlined the steps here for what to do. The first thing we want to do is group our x terms together and group our y terms together on one side of the equation, and then you move the constants to the other side. And once we've got that set up, we want to complete the square for both the x terms and the y terms, always making sure we're balancing our equations. And then we're going to want to factor so that we can get our equation in standard form. So let's look at this first one. You notice here that we could go on and group our x terms and our y terms together and then move the 8 over. But I start looking at all these coefficients, and guess what? I see that all of these could be divided by 2, every single one of these terms, just to make our lives a little bit easier. So if we divide everything by 2, I get x squared plus 16x plus y squared minus 6y plus 4 equals minus 60. So now, remember, I wanted to get my x terms together and my y terms together, which they are nearby, but I want to move that constant to the other side. So I'm going to subtract 4 from both sides. I've still got x squared plus 16x. I'm going to leave a little bit of space right there, and so I can complete the square. And then I have y squared minus 6y. I'm going to leave a little bit of space. And I would subtract 4 from both sides. I get minus 64. Now, when I complete my square for my x terms, I'm going to do just like what I've done before. I'm going to take 16, I'm going to divide it by 2, and then I'm going to square it. 16 divided by 2 gives me 8, and 8 squared gives me 64. So I'm going to take this 64 right here, and I'm going to add it to the other side. Because in this situation, I'm working on both sides of my equation. So I added 64 on the left side, I have to add 64 on the right side. So now we've completed the square for our x terms. Let's do it for our y terms. So we do 6 divided by 2 squared. So 3 squared gives us 9. If I added it on the left side, I'm also going to add it on the right side. Now, just like we've done before, we want to factor this because it's a perfect square trinomial. This is going to factor into x plus 8 squared, y minus 3 squared, and then on the right-hand side we get 9. And this sets it up nicely for us to pull the center. So our center here is going to be at negative 8, 3, and our radius is just the square root of 9, so our radius is just 3. So we were able to pull all of this by getting our equation in standard form. Now I want you all to work on this next one. I'm going to pause the video. Try to work on completing the square and getting your equation in standard form and pulling the center and the radius, and come back and check your answer. So looking at this equation, I did have to rearrange my x and y's to get my x terms together, my x squared and my 8x, and my 2y squared terms together, and then I moved that 28 to the other side of the equation. So I had to do that before I completed the square, and you see how I completed the square there and balanced on the other side of the equation. And then I was able to factor to get my equation of the circle in standard form. And I pulled my center at negative 4, negative 1, and then I had to take the square root of 45 to get my radius, which is 3 radical 5.